welcome to this video where we would be talking about a new binary search method, which is recursive binary search. Okay, so let me name it recursive, recursive binary. And directly let's deep dive into the code. So the recursion method, what is the meaning of recursion? Recursion means that the function is calling itself till the work has been done. Okay, so how to do that? Let me just first close this, and let's start writing the code, and then I'll explain you how. Again, let's start with making the function def binary underscore search. Okay, binary search, and again I need list. Let's name it list 1. Low, we need the low, we need the high, and we also need one more thing, that is n. Okay, now the next thing, that is, what do we need to do? We need to check the base for the recursive function. Now if low is lesser than equal to high, and so what we will do, definitely, or else it will go on and on and on. That's the reason we are doing this. All right, so now we'll find out mid. What is mid? Mid is equal to low plus high, double divide so that you get an integer 2. Okay, so if, now let's start with the next part, that is, if the list 1 mid, if the element is available at the middle or not, that's what we are searching right now. Okay, is double equal to n, then simply you can return mid. Okay, return mid. And if this is not the case, that means elif, what's the next thing you need to do? That is, elif, you need to check for the left part. So for that, list 1, again mid, we are checking the left part now. Okay, so that makes us write this. I will return. Now comes the fun part. See, this is what I mean by recursive. I will again call this function. Okay, but now the arguments will change. Now the arguments will change to list 1, low, and then to mid minus 1. Okay, since we are now changing, and one more thing, that is n. Okay, and 1, if this is not the case, we'll search towards our right. I'll explain you again, I'm just coding it right now. Okay, else return, what do you return? Binary search. Now again you have list 1. With list 1, what's the next thing? Mid plus 1. Okay, next you have high value, and then n. Okay, so these are the values. This is about this this if else, that means this is if else related to this 3 conditions. This if is still left. Okay, so if this is not the condition, that means the element is not available in the list. Okay, so for that I'll write down else, and simply I'll return -1. return -1. Cool. Now the next part is function call. We need to give it the list and also the function, right? We need to call the function. So I'll just use simply this this two, Control C, and I'll just close Control V. Cool. And the next thing, what do we need to do is we need to put result, RESULT, is equal to, again, call binary search, and I'll simply give it, feed the values as list1. It starts from 0. The length of the list is len, the high value is this LELIST, list1, and -1 definitely, because that is what the length is. Now one more thing is n, which we need. Okay, now our common statement, which we have written it everywhere, that is if result is not equal to minus, or maybe we can go with equal to -1 this time. Yeah, equal to -1, equal to -1, then the element is not present. Print ELEMENT is not present, else the element is present at the place, right? So that means I can simply write down str and what is it, re result. So let's try it out if it works or not. So yeah, element is not present, right? And let's try out with 8. Yes, the element is present at 7. So it works. So now let me explain it to you again so that it will be clear for you that how is this thing working. So in the above, like it is more or less a little bit similar to the previous program where we are working with middle, high and low again. But over here we calculate exactly similarly the middle number as we have done in the iterative part. We have used if statement to proceed with the binary search. If the middle value is equal to the number which we are looking for, it will return the middle number. If the middle value is less than, then we'll again call the recursive function and increase the value and work on it again and again till we find it out. Similarly, if we don't find it out in the lesser side, we will go to the greater side, that means on our right side, and recursively call the binary search again and again to find out the value. Okay, and in the last part, this part, we have just written it just like any other program, that if you find out -1, then an element is not present, else the element is present. Okay, so this was all about binary search. I hope you find this interesting. If there is any question, definitely feel free to comment down below. And yeah, that's it for this video. Let's meet in the next video where we will be learning about sorting, different sorting techniques. Okay, so we'll have a new topic in the next section, in this section itself, in the next class. So till then, stay safe, happy practicing Python. All right.